Okay, this is the second time I've done this video. It did not work the first time, but there we go. So today we're going to do area of a parallelogram. Now, a parallelogram, which has one R and two L's, so make sure you spell it, well, three L's, but two double L's, one pair of double L's. Please make sure you spell it correctly when you're spelling it. Now, parallel means that lines never meet, okay? So if you think about a train track will have two parallel lines, and those two lines are never ever going to meet no matter how long the train track goes, because if they did, then the train would fall off the track. So here is a parallelogram. I hope you can see it all okay. Now, on the parallelogram, we have got two pairs of parallel sides, which makes it a parallelogram. This side and this side are parallel, so those two sides are never going to touch. We know that they are parallel because this one has one arrow on it, and so this one, which also has one arrow on it, has to be parallel, okay? This side has got two arrows on it, so the parallel side to that must be the side that has also got two arrows on, which is this one, okay? That makes it a parallelogram. Now, if I want you to think about a parallelogram as being a rectangle that is slanted, okay? So all that's happened is, this originally was a rectangle made by those dotty lines, and all that's happened is the rectangle has been like that, and it's gone, okay, it's like it's drunk, it's tilted on its side, its top has gone boom, okay, and it has been made pairs of parallel sides. That makes it a parallelogram, which means that when we are calculating its area, it's very straightforward because it is just like a rectangle, and it is just the base times the vertical height. And the vertical height, again, we mean to be the height that it makes with the ground when it is at right angle. So that height there, okay, that vertical height with the ground, it has to be the height at a right angle, okay. So here is a little example. Here we've got a parallelogram. Its base is 8, its vertical height is 6, so it is the 8 times 6, which is 48 centimetres squared. That should make areas of parallelograms fairly straightforward. Okay, if you are given the slanty height for whatever reason, okay, then you can ignore that height, you can ignore this length and just do base times the vertical height. It's the vertical height that you are interested in. Okay, right, we are then going to go on to trapeziums. Now, here is a trapezium. A trapezium is a four-sided shape with one pair of parallel sides. Okay, so this is a trapezium here. He's got four sides and it's got one pair of parallel sides. This is a pair of parallel sides. Now you can rotate the shape, and that would also make it a trapezium. And you could also have a trapezium where the parallel sides are at right angles to each other. Okay, so whereas here they're not, here they are. You might not see arrows on these parallel sides because they're at right angles to one another. That means that they are parallel. Okay, so if you just saw a trapezium with no arrows but with right angles, that would also make that a trapezium. Okay, now there are two methods to find the area of a trapezium. There's a formula and there's a song. Okay, now I'll talk to you about the formula first, although I think that you won't remember it as easily as the song, and I'd like you to try and use the song if that helps you more. Now, in my experience, people prefer the song, so we'll see what you prefer. Okay, we're going to call the two parallel sides A and B, and we're going to call the vertical height in between them H. Okay, again, that is the vertical height, not the slanty height, the vertical height at right angles. Okay, now the formula for the area of a trapezium is then a half lots of A plus B times by the height. Now, so what we're effectively doing is we're adding our two parallel sides and halving it and timesing it by the height. Okay, now that, put more simply, is by doing this. You halve the sum of the parallel sides and times the distance between them. Now, if I was in your lesson today, I would be singing that. Now the song goes, half the sum of the parallel sides and times the distance between them. That is how you find the area of a trapezium. Okay, and hopefully you'll always remember that song. So let's fly on with some examples then. Okay, we're going to use half the sum of the parallel sides times the distance between them because that is the same as the formula. So when I'm saying sum, I am meaning that you are to add. Okay, so here we go. We are going to add our parallel sides. Our parallel sides are 8 and 10. We are adding those together to get 18. We are then going to half it to get 9. And we're going to times them by the distance between. Now the distance between is 5, it is not this slanty height, okay? So 9 times 5 is 45 centimetres squared. Similarly, if we had a trapezium that looks like this, to find the area of that trapezium, we have been given the slanty height as well as the vertical height. That means you can ignore the slanty height. So we are going to add our parallel sides. 10 plus 3 makes 23. 10 plus 13, sorry, not 3. 13 plus 10 makes 23. Those are our parallel sides. We are going to half it. Half of 23 is 11.5. And then we are going to times by the distance between. Now the distance between is the vertical height. This is the distance between our two parallel sides, not this. This is too slanty. It has to be the vertical distance between your two parallel sides. So we're doing 11.5 times 4, and you should get 46 centimetres squared. That is how you find the area of a trapezium and a parallelogram.